This talk is about uniform distribution, continuous uniform distribution, which is recognized as a uniform distribution. But before this, I talked about discrete uniform distribution, and I brought up the example of rolling the dice, which has 6 outcomes, and the probability of all outcomes are equal. Now, think of a dice which instead of 6 faces, it has 6 billion or 600 billion or 600 billion faces, such that on each face we have a potential number between 1 and 6. How many real numbers are between 1 and 6? Integer numbers are 6, but real numbers are infinity. Sum of all probabilities for a value between 1 and 6 is 1. There are billions and billions and billions probabilities. Therefore, 1 must be divided by a very, very large number, practically infinite numbers. Probability of all values are equal. They are between 1 and 6. What is the height of the probability distribution function? That is height multiplied by width. Height, we don't know x. Width is 6 minus 1, which is 5. 5x is equal to 1. Therefore, this height is 1 over 5. It was 1 over 6 in discrete distribution. We talk about 3 continuous distributions: uniform, normal, and exponential. In normal distribution, this one, the probabilities gets smaller as we go away from average. Probability of small numbers and large numbers are small. Probability of numbers close to average are large. In exponential probability distribution, probabilities of large numbers are small, and probabilities of small numbers are large. In uniform probability distribution, probabilities are equal. Probability of a continuous random variable to be less than or equal to a specific value is computed as the area to the left of that value. Graphically, we can show the area, and then later we can numerically compute that area. Probability of the random number to be between 2 values is computed as the area between those 2 variables. Or it can be computed as this area minus this area. This area minus this area. This area minus this area, if we are concerned about the probability between 2 values. So probability of everything from negative infinity to positive infinity is 1. Probability of x being less than or equal to something is computed as the area from negative infinity to that value. And probability of the continuous random variable to be equal to a specific value is 0. This is a uniform distribution. It has a lower bound and upper bound. The lower bound, we show it by A, the upper bound with B. Sometimes we show the lower bound with L and the upper bound with U. The probability of x being less than or equal to a specific value, we also show it by capital F of that specific value. And that is the probability to the left of that value. That is the specific value, and the probability is that area. The probability of x being greater than or equal to a specific value is the area to the right of that value, or 1 minus the area to the left of that value, or 1 minus the area to the left. The probability of a random variable to be between two values is computed as the area between those two values. Or it can be computed as the area to the left of the larger one minus the area to the left of the smaller one. For a random variable which is between A and B, this is a representation. Average is A plus B divided by 2, and variance is B minus A squared divided by 12. Don't worry about how to prove this formula. You can even write it on your exam notes or quiz notes. Let's assume we have a uniform random distribution. Perhaps the volume of gas that you put in the tank of your car. X is the value of the random variable. It is between 10 and 20 because this distance is 10, 20, and therefore 10 is here. And this area is equal to 1. Therefore, this height is 1 over 10, or in general, it is 1 over B minus A. That is f of x. And x is less than or equal to 20 and greater than or equal to 10. Average is 20 plus 10 divided by 2, which is 15. Variance is 20 minus 10 to the power of 2 divided by 12, which is 8.33, and standard deviation is equal to square root of variance, or square root of 8.33, or something slightly less than 3. Now let's back to our imaginary dice. Suppose waiting time in a line is uniformly distributed between 1 and 6 minutes. Compute f of x. The total area under the curve is 1. The width is 6 minus 1, which is 5. The height is 1 over 5. Then 5 times 1 over 5 is 1. What is the probability of x equal to 3? There are infinite real numbers between 1 and 6. Probability of x being equal to a specific value is 0. Because probability of x equal to 3 is 0, probability of x not equal to 3 is 1 minus 0. And what is the probability of x less than 3? The probability of x less than 3 is the same as probability of x less than or equal to 3. In continuous probability distribution, instead of less than or greater than, we always have less than or equal and greater than equal, because probability of equal is equal to 0. Probability of x less than 3 is equal to probability of x less than or equal to 3. And it is this area. The height is 1 over 5, and we wanted to compute the area between 1 and 3. 1 over 5 times 3 minus 1, which is equal to 0.4. Probability of x greater than 3 is the same as probability of x greater than or equal to 3. And probability of x greater than or equal to 3 is 1 minus probability of x less than or equal to 3. Equal is in both of them because the probability of x being equal to a specific value is 0. And we already have the probability of x less than or equal to 3, which is 0.4. Therefore, probability of x being greater than 3, which is equal to probability of x being greater than or equal to 3, is equal to 1 minus probability of x being less than or equal to 3, and that is equal to 1 minus 0.4, which is equal to 0.6. Obviously, we could have also said this width is 6 minus 3, and this height is 1 over 5. Therefore, that is 3 over 5 or 0.6. Probability of x greater than or equal to 0 and less than or equal to 4. It is not 4 minus 0 times 1 over 5. It is not 4 over 5 equal to 0.8. Why it is not? Because the lower bound is 1. Therefore, probability of x less than or equal to 4 and greater than or equal to 0 is equal to probability of x less than or equal to 4 but greater than or equal to 1. And that is 1 over 5 times 4 minus 1, not 4 minus 0. Probability of x greater than or equal to 2, and I have a typo here, less than or equal to 7. Probability of x less than or equal to 7, greater than or equal to 2. We don't go up to 7. The maximum value we have is 6. Therefore, probability of 2x less than or equal to 6. And that is 1 over 5 times 4. So be careful. Probability of x being less than lower bound and probability of x being greater than upper bound is always 0. The lowest 25% of observations of the random variables is bounded up by what number? The problem is asking for what is the value here such that the probability to the left of that value is 25%. So if this value is x, we are talking about x minus 1, which is the width, multiplied by height, which is 1 over 5, and that probability should be equal to 0.25. So if I multiply this 5 by this 0.25, I will get x minus 1 equal to 5 times 0.25, which is equal to 1.25. And if I take this one from left-hand side to right-hand side, x is equal to 2.25. The highest 30% of observations of these random variables are bounded down by what number? Is asking for this value such that the probability to the right of it, the probability of numbers which are greater than this value, is 30%. So if I have x here, then the width would be 6 minus x. 6 minus x is the width. The height is 1 over 5. And this should be equal to 0.3. If I multiply this 5 by this 0.3, that would be 6 minus x is equal to 1.5, and x is equal to 4.5. We could have also said if probability to the right is 30%, then probability to the left is 70% because probability of everything is 100%. In that case, here I have x, here I have 1, x minus 1. The height is 1/5, and the area to the left is 0.7. That would give me x minus 1 equal to 3.5 and x equal to 4.5. The same thing.